All right, welcome to week 2. Sorry about the mix-up last week. I don't know why I used the wrong link, but happens sometimes. We're on the right link now. So before I get into the stuff I want to talk about for week 2, does anyone have questions for week 1 or questions on week 2 that's bothering them, or questions about anything that I can help? Can everyone hear me? All right.
Can hear you. You're good.
Okay. If there are no questions, I'll go ahead and start talking about week 2. And feel free to stop me if you have any questions. I'm going to recover the reverse engineering assignment for this week. I'm going to show you some code samples, and we'll talk about a little bit what's expected this week. So let me share my screen here. Okay, we're shared. And let me go to here. Okay, so this week in week 2, make this a little bigger here. That's what I like. Okay. So your reading assignment is chapter 3. And like I said in the PowerPoint slides, and like I said last week, and I've said it before, the book is not a pleasant thing to read. It is not a mystery. It is not a fiction. It is a reference book on how to write code. I have yet to find one that's enjoyable to sit down and read. It is great use as a reference book. It's got an index in the back. Feel free to, if you're looking for like suck queries, go to the index, find select, go to that page, read how suck queries run. If you have the tenacity to power through this book and read like a novel, more power to you. It's something I could never do. But it's an excellent reference book and will give you everything you need on that. The rest of these are all about what a relational database model is, how to reverse engineer it. So real quick, let's talk about what a relational database is. So y'all, so I'm sure y'all are familiar with Excel, right? Okay, so Excel is a database model, believe it or not. Anything, a piece of paper with information on it is considered a database, because a database is anything that holds information. A relational database model is when you have multiple pieces of paper that can all talk to each other and share their information. Okay, and we'll go ahead and take a look at the Sakilla database here in a second. We'll kind of talk about how that works and how. So you have all these pieces of paper, we call them tables, and the information in those tables relates to each other. If for some reason I shoot off the side, I'm trying to chase the dog away from the cat food. So don't think I'm running away. I get this dog. My dog is staring at the cat food and waiting for the cat to move, and I can't have that. Anywho, so it's tables with specific information, and it ties to other tables. So you have all these things that can correspond and talk to it. Let's just go ahead and take a look at the Sakilla database and kind of discuss this. So over here in the Sakilla database, we've got an actor table, and that holds information about our actors. Actor name, first name, last name, and the last time it was updated. We've got the address table. We've got the categories table: city, county, customer, film actor category. So the actors table will hold information about the actors. The customer table will hold information about the customer. We want this information segregated in such a way that each table holds information that only has to do with what that table is about. Okay, there's something you'll start reading about, and we'll talk a little bit about as we go along, particularly for those of you who do the final project. We're going to talk about the degrees of normalization. Okay, there are basically 2 rules you should never break in a database. Number 1 is never have redundant data in your database, meaning never have the same information in more than one place. So if you have a customer's address, that goes in one place, not 2, not 3, only one place. And we'll go through that and see what that looks like. The second is the information in the table only directly corresponds to the title of the table. So let's look at the actor table. So the actor tables, it's actors got first name and last name. There's other information we could put here that's prevalent. That means that's important to actor, like date of birth, place of birth, That's something that would be there. What else would be like hair color, eye color, things that deal with that actor. We wouldn't put the title of the movie that they're in that table, because if they're a good actor, they'll be in more than one movie. So we couldn't have a column here that said movie, because a good actor more than one movie. So we can't have like movie one, column movie two, column movie three, and so on, because we don't know how many movies this actor is going to be in. And that really is not prevalent. That's not really specific information just to that actor. Okay. So under customer, we got first name, last name, their email address, their address ID, which goes back to the address table, the store ID, which goes to what store they use. So they've got a home store. So again, it's only information that deals specifically with that customer. Over here, we've got the film table. And in this film table is we've got film ID, title, description, release year, language ID, rental duration, rental rate, things like that, but only with this movie. But notice we don't have actor name in here either, because if it's a good film, it has more than one actor. Okay. So, excuse me 1 second. Get. So we have more than one actor. So what we need to do is we need a separate table. So I've got this table called film actor, right? And in here, I've got an actor ID column and a film ID column. So this table is going to tell me what actors in what film, just going by the ID column. Okay. Hi, Aaron. Hi, Aaron.
Hi.
Now I call these bridging tables, or you can call them whatever you want. But so what happens here is there's 3 relationships that you can have in a database. There's a one-to-one relationship, a one-to-many relationship, and a many-to-many relationship. And the only forbidden relationship is the many-to-many. We don't want many-to-many relationships. A one-to-one relationship is here, one customer has one address. So I've got an address ID here, and in the customer table, I've got an address ID. That's one-to-one. One customer will have one address. Okay. One customer will have one store. Okay. But the second we get into the point like films and actors, one actor might be in many films, and one film might contain many actors. So if we try to join these 2 tables here, this would be a many-to-many relationship. So we need to bridge it to where we have this film actor table here. So one actor might be in many films, so their actor ID is here, and one film might contain many actors, so the film ID is here. So here, this table to the actor table is one actor to many films, and this table here is one film to many actors. So these are one-to-many relationships. Is this making sense? Y'all grabbing this? We will talk about this every week from now until week 14. Particularly when we start hitting week 5 or 6, when people are doing their projects. This is just kind of like let's get the general idea on how a relational database works. So basically what this means is all of these tables have relationships with each other. Okay. Just because, so how would, so, and then see, they all link together. I wish I'm gonna get this, let me reverse engineer this if I can. Is it hard? That is there. Okay, nope. Where's my? It's blocked over here. You know, I'm going to leave this for next week. We'll talk more about schemas. Just as long as you're getting the basic idea of how these relationships work. So we've got all these date tables, and all these have relationships. Customer has a relationship with address. Actor has a relationship with film. Film has a relationship with category. Film has a relationship with language. Okay. So there's that. It's not my intent to dive into that today, but hey, why not? We did it. Okay. So let's talk quickly about this reverse engineering website. So I talked to Liz about this last week. So all I want you to do is find a website that has some sort of database backend. And last week I showed you this one here. Okay. It's a gaming website that I go to under card games, Magic the Gathering. Go here to, I don't know, here, Crimson Vow. So this obviously has a database backend because all this information is coming from a database. So because here's your how many are in stock, how much it costs, something like that. So I want you to find a simple website that you can say, okay, here's what I think the database on the back end looks like. This may seem like overwhelming for you guys, and it's really not. I mean, there's nowhere wrong. It's just basically showing me what you understand about how databases work on the back end. You have these wonderful over here, like how to reverse engineer your website database. There's 3 things here that you can utilize to help you understand what it is. And you need to make a quick video, 5 to 10 minutes long, that tells me, here's what I think the back end of this database looks like. Here's what I think the tables are. Here's what I think the relationship between those tables are. So if I were doing, I'd say, okay, so obviously they've got a table for products and they've got a table for versions, and the 2 tables must be related this how. They've got a table for costs, or they got a table for you get down here to individual cards. So just kind of like give me an idea of what you think the database looks like, what the tables are, how they work together, what information is held in each of them. But the important part of this assignment is 2 things. One is that you start showing me you have a rough idea on how database works. And again, there's no wrong answers. This is whatever you think it is. It's starting to learn the learning process, right? And the other part is this. Who is here? Let me see. Let me bring this out here. Have y'all ever had to use Proctorio before? Who here? Let me see.
Yeah.
Who's here? Yeah. So Proctorio is a horrible piece of software.
Yeah. It sucks.
Yeah. So in order for you not to have to use Proctorio for this exam, you have to do a short video presentation for me in week 2. And if you do that, I check the box, no Proctorio, the world is a happy place. Okay. So this is our gift to you, not using Proctorio, but you got to play ball with us and give us a 5-minute video about how a database is designed. Seems fair to me. Sound good?
Awesome. Thank you.
You're welcome. I wish it was my idea, but I will take credit for it because, hey, the person who came up with it is not here. So that's that. So that's the big written assignment. It's not a written assignment. It's the big video assignment this week. It's your paper that you have to do. And before I get into the code examples for this week, again, let me plug. So next week is the week 1 where we talk about the final project. The final project is when you guys pick an application that you'd like to see made, and you design the back-end database for it, and how you think the database should build. And we work on it for 9-10 weeks, and we go through iterations and we design it. You guys build it, and I help you out. And by the time you're done, you've got a really solid back end for a database, for an application that you want to make. During that process, you'll also give me a mock-up of the front end. You'll do a whole bunch of case studies and data manipulation. And that is so you don't have to take the final exam. So if you do the final project, there is no final exam. You just turn in the project. They're both worth 180 points. You can do one or the other. It doesn't matter. You can decide to work on the final project until like the day before the final exam, and then take the final exam and say, you know, I just this isn't going to get done. Just fine. If you choose to do the final project starting next week, with your weekly papers, you will no longer use the writing prompt that is with the weekly paper. Instead, you will give me a quick 3 to 5, probably leaning on the 3-paragraph side, summary of your week's activities with your final project. So like how you came up with the idea of what you wanted to do, how you designed the tables, what questions you have, what concerns you have, where you're kind of lost, where you're gaining strides, things like that. So as of week 3, if you do the final project, it becomes, your papers become more of a, here's where I am with my final project, as opposed to you work for a company and they just taught you how to do select statements. What do you think about select statements? Okay, so choice is yours. As for the final exam and all the quizzes, I don't know if I touched on this last week. All the quizzes should be 2 attempts. You get 2 attempts on them. There's no time limit, and they're all open book, open notes, open websites, open whatever you need to be. Okay. The final exam is 2 attempts, and it's open book. Okay. So go whichever way you want. I think the final project is really, really cool because really this is a database administration and design course. And the design part is the project. So if you want to lean into the design side of it, let's do the final project. It's a lot of fun. If you want to do the admin side of it, lean into the final exam. That works too. Any questions on the final exam or the final project? Okay. So then let's talk about this week's assignment. And this week's assignment is all about select statements. So what we're talking about today is how we get data out of a database. And I will give you guys a video that I made on this a couple of years ago. Let me get this out of the way here. Okay. Oh, real quick before I get to here. So last week, people were contacting me about they're getting errors. So I will tell you something about database systems and errors. Database systems do not give you errors that make any kind of sense. They'll give you some kind of abstract, occasionally there'll be one that makes perfect sense. It'll say, cannot insert duplicate row, or foreign key violation, and it'll make sense. Sometimes you'll get things that are just a number. And last week, there were a number of you who had problems with this. So I'm creating a user called Flat Stanley, and it created it, no problem. Down here is where the results are. And if I do it again, I get this error code 1396, operation failed. Doesn't tell me what happened or why it failed or what was going on or anything. If you take this error code and just run a quick Google search on it, it will give you what happened 90% of the time. And the people who are having this problem, what happened was this is a very touchy thing. When you do this, so it'll run it and you may not notice that it ran successfully. And the problem here was the user, what this should have said is error code 1396 user already exists. That would be a great error. That would make a lot of sense and people would understand it. Create user failed. We don't know why it failed. But if I drop the user, it works again. And if I create it, it works again. So if you get error codes, pop it in the discussion and say, hey, I got this error code. I don't know what it means. Or better yet, throw it into a Google browser and it'll tell you what it is. And 90% of the time you'll go, oh, that's what's wrong with it. It makes sense now. Okay. So select queries. When data is put into a database, it's not really put in there in any way, shape, or form that an end user can understand. The job of the DBA and the developer and the coder is to pull the data out of the database in such a way that the end user can look at it and understand what it's talking about. Especially when the data is held over several different tables. We need to take that data and put it out so people can understand it. Today, I'm only going to talk about the basics of a select query. I'm going to talk about how a select query works, how the engine does it in the back end. And we're not really going to talk about how to join table. I think somewhere here I do join a table or two, but that's not until week 4 or 5 how you combine the tables together. Today we're just going to talk about some very basic commands that you use and how to bring the data out. So there's 2 types of code that we're going to talk about. There's DDL code and DML code. DDL stands for data definition language. Data definition language is anything that creates, alters, or drops a thing in the database, like a table or an index or a view or a procedure. That's DDL, data definition. You're defining what the data looks like in the table in there. So there's create, alter, and drop. Okay. DML is data manipulation language. That's whenever you're taking the data out of the tables and presenting it. That's your select queries, your update queries, your delete queries, and your update queries. Okay. Those are your DML codes. DML coding. So DML, data manipulation language, DDL, data definition language. DDL is create objects. DML is manipulating data with your select queries. So today we're talking about DML code with your select query. In your select query, you have two basic words you use, select and from. This is what I love about T-SQL. It's English. It makes sense. Select column from table. That's English. Select item from menu. Select dog from puppy farm. Select, whatever. It makes perfect sense. It's very simple. So here, if we look at this, I have select first name and select last name from the customer table. I'll go over the customer table. I've got first name, last name, email address, so on and so forth. So I'm saying, show me the first name and the last name from the customer table. And if I run that, there it is, first name and last name. It's not in any kind of order. It's just whatever it saw first, it put there first. Okay, so there you go. If I did this though, if I had a customer ID. Oh yeah, by the way, when you're writing your queries, and this is why I say use Workbench, you can just drag the columns over. It's a really great cheat. If you don't like to type like me, just drag the columns over. Make sure you put a comma there because then it'll work better. So I do this and I do that. This is in order. Okay, so the order it came in was the order of the customer ID. Okay, now the customer ID is known as the primary index or the primary key. This is the one column that the index of the table is indexed on. Okay, anytime you do a select query from a table and you do not specify the order you want it in, it goes by this order. Okay, the primary key is the default order of the table. If you do a select query that does not have a sort criteria, it goes by this. Okay. So here I'll do, I don't know why I did that here. So here, I'm going to build on this one here. Now I've got a new command here, two new commands here. I've got order by. That's my sort clause. I tell it what to sort it by. It can be last name, it can be first name, customer ID. Anything you put there, it will sort it by, be it alphabetic or numeric. Okay. I've also got another command here called concat. So concat means concatenation. That's when I take a number of different text blocks and combine them into one. So if I run this here, like so, I get last name and first name in two separate columns. Okay, I don't want them in two separate columns. I want them in one column because I want to present it to the end user as just a name. So here I'll put concat last name and a comma, and then in single parentheses. It's important when you're using any text in T-SQL. It is a single quote, not a double quote. A comma and a space, closing that quote, comma last name, first name, and then I use this. So let me do that. Let me get rid of this first here. And let's run this query without that and see what happens. So here we've got select, and I'm concatenating the last name and the first name with a comma between them from a customer, and I'm ordering by last name. So here I run this. And now my column name, like when I do this here, my column name is last name and column name is first name. When I run it like this, my column is concat last name, first name. I don't think an end user is going to understand what that is. It's not pretty. It's not comprehensive. It's just whatever that select clause was. So if I put here, if I put this back and say as customer, when I run this, it's going to call the concatenated column customer. Okay. Also, I can take this here and put it here. Oops. And it will sort by that. Okay. With your order by clause, you've got two different things you can add to it. You've got ASC, which is ascending, which is A through Z. And you've got descending, which is in reverse order. Okay. So select from order by. Everyone doing good? Everyone following? Give me a thumbs up. All right, good. Same thing here. I'm just adding store ID to it. Same thing, store ID, customer, and let's order by store ID just for fun. Okay, and I can do this. Order by store ID and customer. So it'll order by store ID first and then by customer. Okay. Now we add a new command. Select store ID. And the concatenation of customer and last name and first name from customer, where last name like D percent sign, order by store ID last name. So what this is saying, get me this information from the customer table, but only where this criteria is met. So only where last name is like D. So anything that has last name that begins with a D, it's going to give me. And then we're going to order by last name and for store ID and last name. Okay. This is like fun stuff, and it's super easy stuff. So here I'm going to take real quickly and tell you how the engine, the machine behind the engine behind the thing, actually runs this query. Of these first four criteria, the select, the from, the where, the order by, which do you think is run first? Which do you think the engine runs first? Do the select part, the from part, the where part, the order by part first? It does the where part first. So what happens, and this is why the size of tables becomes very important. So you cannot manipulate any data that is on a hard drive. Any data to be manipulated must exist in the RAM. It has to be in the active memory. It can't be sitting on the hard drive. Anything on the hard drive is static and can't be changed. You change data, you pull it into the RAM, it changes there, and you write it back to the hard drive. Does that make sense to everybody? Okay. So when you write a select query, and you say select from where order by, the first thing the query does is, okay, they want, I'm sorry, it does the from first. I'm sorry, it does the from query first. The first thing is, okay, they want the data from customer. Get the entire customer table and put it in memory. So if your customer table is a terabyte, guess what's going into your RAM? Hopefully you have a terabyte of RAM sitting on that server. Okay. Don't worry about your tables being terabytes. I've seen tables that are terabytes on giant servers, and we have terabytes of RAM in there, but generally speaking, tables are pretty small. So what happens is it grabs that table and puts it in the active memory so it can be manipulated. It can't sit over here. It's got to come to the RAM. Okay. If you've got 2 tables in that from query, 3 tables in that from query, all 3 come into active RAM. Okay. The next thing it does this. It does the where clause. So it says, okay, because remember, when that data comes in, it's organized by the primary ID. So now you're saying, okay, you got all that data there. Now just give me anything where last name is like D, and everything else it gets rid of. Just takes it off the table, puts it away. Okay. And then it does your select query. So it says, okay, now I just want these three. You'd think it'd be smart enough when it pulls everything over just to grab these out of there. So you're only grabbing the 3 columns, but it doesn't, brings everything in. So it does the from first, then it does the where, and then it does the select and just gets those, it gets those columns you want, gets rid of everything else. And then it does the order by. So that's how a query runs in the back end. Okay. And it happens in, you know, that long, like milliseconds. And it really doesn't matter the size of the table. I've seen queries run on tables that were like 7 or 8 terabytes of data in just a table, which, by the way, is a really bad idea. Tables should never get that large. But it comes back in milliseconds. Okay. So there's that. So here, so let's look at, so here, the order by clause here is a little different. So there used to be a way to code things that was very obscure. And I think people did it to keep their jobs. I'm not really sure. There's really bad ways to write queries. And whenever I see it, I figured, oh, this was my guy who's worried about losing his job. So when I look at something like this, and when we get into like week 5 and 6, I'll go specific into what people do to make sure they don't lose their jobs. Select store ID, concat last name, first name, because everything's the same except this order by. I have order by 1, 2. 1, 2. I don't know why people do that, but they do. You can. And if, I tell you this because if you're in the field and you're looking over other people's code, you might see this and now you understand what it is. You can order by cardinality, meaning position in the select query. So this is column 1, this is column 2. There you get ordering by 1 and 2. Returns the same result. It just is a little more obsequious. Okay, now I'm adding another thing called group by here. So you're going to hear me say this many times over the next 14 weeks. Count is what we call an aggregate function. An aggregate function is anything that adds a bunch of numbers together or has anything to do with numbers. I'm aggregating things. If you look down here, this one, this is average. So here, I'm going to get the rating and the average length in the from everything in the film table. Okay. So what this is going to do is this, it's going to find the rating, PG13. It's going to take all the sums of everything in there and then average it. And you're going to get one number back. Okay. So here, I'm going to get the rating. Let me just show you what this is here. So I'm going to do select rating. Okay, if I run this, I'm just gonna get a lot of data. I'm gonna get how many? 1,000 row returns, right? And this is gonna show me all the ratings. So let's say I just want to know how many in my store. I want to know how many R's, PGs. I want to know how many there were. I've got a function called count. I'll run this query. I'll say, go to the rating, count how many of each I have, and return it to me in this aggregate function. If you're, and this is what I'm going to say 1,000 times this year, if you are using an aggregate function, you must use the group by command on any column that is not contained in the aggregate. This is the aggregate. Anything with this is the with a function run is the aggregate. This is not included in the aggregate. Okay. If I ran this without the group by in it, this is what I get. There are not, we looked at this before. We know we don't have 1,000 things that are PG. And just as a sidebar, any other database system, be it Microsoft SQL Server, Oracle, Postgres, MongoDB, this would give you an error. It'll simply say, hey, you're running an aggregate without a group by, check yourself, go fix this. MySQL is much more forgiving and just gives you this bizarre, the first one that came out was PG, and there's 1,000 of them, even though we know That is not the truth. Okay, if G was the first one, it would have done G 1,000. In order to properly do an aggregate function, you have to do select the aggregate from film, then group by, because now you're saying, okay, you're going to do an aggregate, group by these columns. And we do this. And now we get the actual. And if we added these up, we'd get 1,000. Okay. So whenever we use an aggregate function, we must have a group by. Again, here we are. Select rating, average length from film. Okay. If I take out the group by, I get this bizarre thing. It's every movie is PG and everything runs 150. The average is 115 minutes. Okay. Now, this is like a week 5 code, but again, I'm showing you. So here, I'm joining the film table to the language table because I want to know what films we have, what the name of the language is, the rating of the film, and how many of each rating we have. So I want to see the language, the rating, and how many of each how many of each rating in every language we have. So I'm joining the film table to the language table. I'm joining on language ID. I'm using an inner join, which I'll explain more about later. And I'm grouping it by the 2 columns not in the aggregate. Language name and film rating are not in the aggregate. I have to use them. And I'm ordering by the same ones. So let me run this. And this is telling me that in English, I've got 112 G rated films. In Italian, I've got 39 G rated films. In Japanese, I've got 27 G rated films. Okay. Shonda, do you have a question?
Yeah, I was actually back when you were talking about the order by and
Sure.
doing the 1 and 2.
Huh?
In the reading, it kind of explained doing that, and then in the quiz we took on the exercises, so like the answers in the back of the book in the appendix had the answers with the 1 and 2, and so I just wanted to make sure I'm not going to get marked wrong if I do that.
No, I know what it means, and I know the exercise made you do that because the book was written by a 90-year-old dude. So I get it. It's totally cool. But there's a lot of things in the class as we go through this. The book will say this is how we do things because this is how we did things, back in the Cretaceous. But when you get in the real world and you start doing this stuff, this is how we do it now.
Okay.
So I won't mark you off for that. I won't mark you off for that stuff. I don't. No,
okay,
no,
good.
No, you're
and
good.
then for the for the I just lost the word, but
here
in the
as.
book, yeah. So they weren't using the as.
Okay.
And
so here's the thing. In this situation here, you don't have to use the as. You don't have to. I put the as there because I like writing clear code that's understandable.
yeah, it was really
Yeah.
confusing at first. The examples didn't have it, and then he explained why, but
yeah, and you don't have to put it there because if you look over here as well, I'm using so this is funny here. So basically what we're doing here with the as, I'm giving this an alias.
right.
Okay, I'm giving this an alias. I don't have to put the as here, but I like doing it just because it's clear. It makes the code clearer, right? And it's 2 keystrokes. It's not going to kill anybody. Here, I'm aliasing the language table using L. If I put as here, it actually errors out.
Oh.
Okay, so it's confusing. And here's the thing. In Postgres, if you don't put the as here, it doesn't work. Okay. The universal thing across all platforms. So like when we're talking about like PostgreSDB, MongoDB, Microsoft SQL Server, Oracle, MariaDB, MySQL, there's like 20 different versions of this. Putting the as here always works. Leaving the as out works 75% of the time. Okay, so it's just a good habit to get in there, because once you guys understand how MySQL works and how the coding here works, you become T-SQL literate across 12 different platforms. Okay, it's like, and you'll see like in the course of this, I work Microsoft SQL Server all day, so I'll come to this class and forget how it works in Oracle or in MySQL and get things backwards, and it's the way it is. But yeah, so you don't have to put the as there, and I just do for clarity. I like writing clear code.
Okay,
Okay,
that's great. Thank you.
no problem. I have to look. I've never had actually. I keep forgetting to look for the little hand that gets raised up. So if I don't answer you, just like stop me. Just say stop, because I will keep talking until I stop, because I like talking about this. I just really like talking about databases at work. It's just a weird thing for me. So anyway, back to this. So here I've got, again, I'm taking language name, language rating, my aggregate function between the two tables on the language on the ID column, and getting my response here. Okay, and this just is showing you can present data in many different ways. And I'm pulling two tables, and you can look at this going, oh, I understand what this is. English movies, G rating, 112 of them. Okay, that makes sense. Of course, here I didn't give my thing an alias, so now it's count F rating, which whatever that means, right? So here I've got select rating, the maximum replacement cost, and the minimum replacement cost. Two aggregate functions. And I'm going to run this, and it gives me what I want. PG, maximum replacement, minimum replacement. Okay. So again, this just reiterates. I'll get to this because inevitably someone will make this mistake. They'll do an aggregate function without the group by and can't figure out why it doesn't work. Okay. All right. I think I've said that enough. One last thing about the where clause, and then we're gonna open up to questions, and then we're gonna call it a night. Is here where description like, and notice what I did here. I put a % sign on either of them. So that means I'm gonna look for anything that's got DOCU in it. I'm gonna look for anything with COW in it. And if I run this, so documentary. Now here I said and. So both these criteria have to be met. So it's got to have DOCU in a word and cow in a word. So here, documentary, mad cow, documentary of mad cow. If I did this or put or in there, it gets a lot longer. So now one of the two criteria must be met. Okay, so documentary of a frisbee and a lumberjack, the mischievous monkey in a shark tank. I'd watch that movie. I don't know about you, but I'd probably watch that movie. A Fair Prejudice is a weird title for it, but I'd watch it. Okay, so when you get into the where clause, you're going to find a lot of stuff. You've got like, which gives it what could be in. You could do equal, like where title equals a Fair Prejudice. And we're going to talk about more of these. I'm just kind of giving you a preview what to expect. Like, so you can do that. This where clause is very versatile, and you can play with a lot. Okay. But that covers everything from this week, I think. Let's see. Did we talk about select yes, from yes, where, group by, and order? Yep. It's funny, we talk about group by here. And then we really don't talk about joins, because joining is where the group bys get really cool when you get into joins. You have a lot of fun with those. You'll enjoy that part. All right, that covers everything I need to say for today. Do you guys have any questions, comments, thoughts, concerns about now or the future?
I have a question.
Hey, hit me.
So can you go back up to like line 50 right there? Like back down like
Here?
55, 56, right below.
Here? Yeah, here?
Yeah.
Yep.
I don't understand the L period name, F period rating. Like I don't understand the
Sure.
abbreviation there.
Okay, so here's the deal. So when I'm writing in the with the when it doing any kind of joins, right? Whenever I use a column name, I've got to tell the query what table that column comes from. Okay. So here I've got from film F inner join language is L. So what I could do here is I could do this. Right? So this tells the database, this tells the query, name comes from language, rating comes from film, and count comes from film, right? But because I don't like to type a lot, I can do these aliases. So here I'm saying select name, rating, and count from film as F. So I'm telling the query engine, whenever you see the letter F, I'm talking about the table film. So here I'm talking about film, here I'm talking about film, here I'm talking about film, here I'm talking about film. Whenever you see the letter L, I'm talking about the table language. I'm talking about language here, so on and so forth. And this could be like LAG or whatever I want it to be. Okay. So what I'm doing here is I'm aliasing the tables with a short name that's easier to type so I can reference the columns so they know what table the column is coming from. Does that answer your question?
Yeah, that makes sense.
Yeah.
Did you have to like previously alias them that, or does it just like know, like when you type L period name F period rating, it knows that you're just talking about language and film?
Right here is where I aliased them in the from clause. When I said from
Okay.
film F, I'm saying whenever you see the letter F in front of that dot, I'm talking about the film. Whenever you see L in front of a dot, I'm talking about language. So this is
Okay.
where we do the aliasing. Yeah.
That makes sense.
Yeah. I glimmered over that because I wasn't really talking about the joins. So thank you for bringing that up. It's a good question. And again, and Isaac does a good thing. I will sometimes, because I've been doing this for many, many years, I will forget over a simple thing. So please, any question, ask it. It's anything's a good question. Okay. I never say there's anything. I never say there's no such thing as a dumb question, because I used to work in customer service and I know that's not true. But most questions are good questions. So anyway, yeah, that's what the aliasing is. I want to be able to alias it out so I know. And truth be told, unless two tables have a column of the same name, like I have actor that's got first name and customer that's got first name. So if I try to do a query, and I'll do this later, I got queries later on. If I have a join query that's using a column with the same name of both of them, then I have to alias it properly. If I don't, if I ran this one without the aliases, it would be fine, because language doesn't have a name column. Let me see something here. Does language does it? Am I lying? Yeah, language is name, but film has title. Yeah, film has title. So the column name and the column rating don't exist in both tables, just one. So if I didn't put those there, it would work fine, because it can tell. But if I ever do it without the aliasing, I think the error you get is like ambiguous column name, which is a great error. So I didn't mean to confuse the issue, but like, so it's there so it knows which table to go to for what column. Any other questions?
I did have another question.
Go for it.
I noticed that the clauses, like some of them are capitalized and some are not.
Oh.
In your code, does it matter? No? Okay.
So depending on the engine you're working on, no. In MySQL it doesn't, in Microsoft SQL Server doesn't. In some version of Oracle, if it's not all caps, it will laugh at you and not do what you ask. But for the most part, I generally do all caps for commands or for clauses, because I like the way you read it through, but sometimes I'll just get lazy and forget to hit the caps lock. And I probably shouldn't do it. But it's also, I'll just say it's to demonstrate that it is not a case sensitive software.
Okay. That's good because I noticed, you know,
Yeah.
it's capsule, but
Sure,
MySQL,
absolutely.
yeah, it like defaults in lowercase every time, and so even if it defaults for you, you still have to capitalize it. Also, it's annoying.
Now I will tell you, offhand, I don't remember if MySQL is case sensitive, but I can tell you that Oracle SQL Server is case sensitive when it comes to results. So if you did like select, like here with capital D, if in Oracle it had a lowercase d, it wouldn't show up. Okay, well, I'm not sure. Let's see something here. Let me just out of curiosity, lowercase d. Let's remind myself if this is case sensitive. It isn't. Okay, so MySQL is not case sensitive when it comes to results, but just for a quiz show later in your life, or you happen to be sitting in front of an Oracle system where you're getting weird results, Oracle Server is actually case sensitive when it comes to the results. But there's a cheat you can do here, right? So what you can do is do this. Here's a fun bonus query, a bonus clause. So, and that's good. Like, you know, if people do this because like, you know, if someone's like inputting the data and like they go crazy and they hit the shift key in the wrong places and whatnot, you can use upper and lower and force the capitalization or lowerization of everything. There's nothing that you can do to where it just does the first one. I mean, you can, but it's a lot of weird code to do it that way. But yeah, lower and upper kind of fun tricks to do that with. But yeah, so it doesn't matter. I should do it, and I'll try to make sure that I capitalize everything. But like, because this is like this one's got a first letter capital. This is all lowercase, and everything else here is upper. So just so it's because I write these things just before we do this, because I like writing new ones every time. So yeah, anyway, but yeah, it doesn't matter. It's not case sensitive. Some are. MySQL isn't. What is case sensitive? Is Postgres? I don't know. It'll be a surprise when you find out. Why isn't the select query running? Oh, it's case sensitive. Stupid. Any other questions? Everyone all set for this week? Everyone going to do great work this week, get everything done? That excites me. All right. Anyone here thinking about doing the final project? Yes. Yes. Isaac, what about you? Joseph, you guys thinking final project? What are you feeling on this?
Maybe. I haven't decided yet.
The final project is a lot of fun.
What if you did both?
I would just pick the higher of the two.
Okay.
And you know, I mean, I've had people do both, and I just got to pick one or the other. So, you know, it's really hard not to get a good grade. I mean, you really have to not want to get a good grade on the final project. I mean, you have to, it's like getting to Outer Darkness. You really have to want to do it. You can't just wander into Outer Darkness and get there. It's like, yes, I really want to do this. So final project, like, I really want a bad grade on this. So I'm just going to I'm going to give one table and then do that. And then you get a bad grade. So final exam, it's hard to get a bad grade on it too, because it's open book in 2 tries. I mean, come on, we're making this really easy for you guys. For me, and I'm good with that, because I'd rather you guys spend the time and really learn this stuff and really leave this class going, I understand how to code this stuff. Because being able, so we're entering into a world of data science. I don't know if you guys know anything about, do you know anything about data scientists and this whole world of IoT and everyone know what the IoT is?
That's the Internet of Things, right?
Internet of Things. I remember I was at this one conference one year, and like the Lord High God of Microsoft is talking to us, and he talks about the IoT. And when I hear IoT, the first thing I think of is idiot, because of the ID10T errors that you can get on things. Anyways, the Internet of Things is like everything, like your smartwatches, your Fitbits, your tablets, your phones, everything is the Internet of Things. And then here's the term I never heard. There's something called the mist now. So the Internet of Things is all the objects. The mist is all the data that these objects produce. Imagine for a second, people have tablets, phones, smartwatches, Fitbits, iPods, personal computers, and all of these are generating data. Also think like in your home, you've got Alexas or Siris, you've got smart home thermostats, you've got smart refrigerators, you've got Ring doorbells. All this is generating massive amounts of data. There's like petabytes and petabytes and petabytes of data being created every day by people. And it's all out there. Everything is out there. There was at one point in time, there was a store that had, everyone know what RFID chips are? Okay, so most credit cards now come with RFID chips. And there are RFID readers when you walk into the store. And if you've got that credit card in your wallet, it knows it. And if they've got any kind of displays there, and it says, hey, this person bought, you know, Hershey Kisses last week and they're on sale this week. When you walk in, you're going to get a text message on your phone that tells you that. It's like when you go on any kind of social media and you happen to search like, you know, ceiling fans, and you go into Facebook or Instagram, all of a sudden you've got thousands of ads. So this is all data that's being manipulated. There's so much data out there. It's that's why, you know, we used to call like, what is it? What are the new terms? Data lake. That's new. I don't know if you've heard data lake. A data lake is for a company that just has massive amount of data that hasn't been organized yet. You know, like, for example, if you have, what's a good thing? Like, if you have like a scale that's a smart scale, right? And it connects to your smartwatch through an application. Every time you step on that scale, everything about you is recorded onto your phone, onto your watch, and onto the company's website. Okay. And so they've got all this data about you and they have no idea what to do with it. And it just goes into the data lake. And now there's something called, of course, there has to be a data lake house where they sort the data. I just think people need a vacation. They come up with this stuff. They want to go fishing or something, which you can do. Fishing is a hacking thing. But anyway, so when you start learning how to write these queries and how to manipulate the data, you become very, very valuable in this world because there is so much data out there and people don't know what to do with it. I worked for a company one time. It was a title insurance company, and they would go to every county in the United States, and the county would send all the information about every piece of property to my company, and we would take that information and put it into a database and make it searchable for people to find out the titles. When they're buying houses, they do title searches on the houses through our company because we had all the data. But the thing is, they would send us data that like we didn't care about, like how many doors were in the house, or like, you know, whether the property faced east, west, or south, or like all these little things that people buying the house cared about, but we only cared about the title. So my company, in its infinite wisdom, took all that data and stored it in the databases, right? And this is where Maricopa County in Arizona was a 2 terabyte table, not the database, the table with the data that came on the property was 2 terabytes. It was ridiculous. It was too much data. But they had no idea what to do with it, and they don't want to throw it away because what if I wanted to, what if someone says, hey, we want to search by houses, because real estate agents would use that. You know, we want to know how many doors are in a house. I don't know why. Maybe they're superstitious. So that information there, so we'd have to be able to search by it. You know.
So
Joseph.
I work for, I'm a realty specialist for the U.S. Army Corps of Engineers.
Oh wow, okay, that's cool.
And so I am very grateful when companies like that have all that information, because it's a lot faster to get it through a third party than through the county.
Absolutely.
And sometimes, yeah, maybe not a house is, well, yeah, sometimes housing is important of how many doors, because with our recruiters and everything, when we have to find them housing, you know, there's all kinds of federal limits. It's kind of silly.
Yeah, no, that's great. That's why we don't get rid of data, because all of a sudden we think we need it. But I mean, at that time, the company was literally just doing title searches. We just cared about who owned the property before, what county it was in, what the lot number was, blah, blah, blah. But like all this data is recorded. And the point is, it's all out there and someone needs to know how to use it. So take the church, for example. all our temple recommends have barcodes on them. So we get scanned, we go in. You know that data is kept somewhere? You know that data is kept somewhere? They just haven't figured out how to use it yet. Look at genealogy. Could you imagine those databases? How big those databases are, how massive it's because Ancestry.com, the reason why we get free accounts with Ancestry.com is because they're using our database. The church has a massive, and this used to be on paper, like in the 50s and 40s, that database that you can search out was all on paper. So someone converted that to digital. That was a lot of work, you know? But imagine like all the family history and how that, I would love to get my hands on that database. I just want to see that database. I mean, it's I think it's on Oracle or it might be on Hadoop now, but it's a giant backend database with like thousands of tables and thousands of rows of data. But someone's gonna be able to select that stuff out of there, you know. Anyway, I pontificate with this stuff, but if you can really learn how to write these select queries, if you want to get into data science or data analysis and you know how to manipulate data, you become invaluable. You really do, because they need people who can like make sense of this data and present it in such a way that, you know, other people can make sense of the data. So anyway, enough of my preaching on this one. But yeah, so like I said, if you do the work, you're gonna get good grades in the class. But to me, it's more important that you understand what's going on. If you understand what's going on, you do the work, the grades will follow. But the final project is a lot of fun. You know, sitting down and like designing a database from scratch, how the tables work together. It's really great exercise in understanding. And to Joseph's point, you could do both. Or like I said, I've had people who spend like 12 weeks on the project, and then something happens, and they don't have time to finish it. They just do the exam. So, and I don't know if I posted anywhere. I take late work up to week 12 because I have yet to have a semester where someone hasn't had a baby, someone hasn't had someone die, someone hasn't had to move out of the state. I had one dude who was in Nicaragua once and was hiding from like the insurgents that were like attacking his city. I'm like, dude, keep your hand on the table, get your stuff in when you can, you know. And then I can't tell you how many people have had COVID in the last, you know, 2.5 years. So that's always fun. But I just want you guys to do the work, enjoy the work. I want you to enjoy what we do because this is a lot of fun and understand it. And then the grades will sort themselves out, I think. Anyway, that's just what I think. Any other questions? That we are at time, and I gotta convert this thing and put it on YouTube on my YouTube channel. So like and subscribe. Ridiculous things to say. But any questions, comments, concern before we close? Awesome. Okay, guys. Get the work done this week. If you have any questions, text me, drop me a note on thing, and if not, I'll see you guys next week. Okay.
Thanks so much.
You're welcome. Night, guys.
Thank you.
Good night.